Python programming series. This is a part 2 video from the module 3. Before starting this video, if you are new to Explore Electronics, then subscribe to it for more video syllabus explanations. Let us start with the topics covered in this video. Numpy. About Numpy, the basic details about Numpy and shape of the Numpy. Slicing, how we use the slicing. Masking, why we use masking. Broadcasting and data type in the Numpy. These are all the topics covered in this video. In the previous part, I have explained the dictionaries, basics, dictionary operations, dictionary methods and aliasing and copying. These are all the topics covered in the part 1. Make sure you watch the previous module and previous parts as well for better understanding. If you understand the basics, then you can easily understand the advanced concepts. Let us start with the basics of the Numpy. In the basics of Numpy, they have explained that what is the disadvantage, where we got the problem and how to overcome it. In that process, they have found something that Numpy. Let us see the disadvantage. After that, how to overcome using Numpy. Normal Python data types are not suitable for math operations. For example, a is equal to 2, 3, 8. I have taken an array that is a is equal to 2, 3, 8. If we want to multiply an integer 2 into a, replication of that a 2 times. I have a is equal to 2, 3, 8, which is the replication of 2 times 2, 3, 8 and 2, 3, 8. This is how exactly it will work. And if we try to multiply by a float 2 into 1 into a, it will show an type error. Why? Because it is not allowed to multiply. To solve this using list, we have tried to solve this problem by using list. Here it will be a lengthy process. Why? Because we have to take the values and create an empty list for the result. After that, we have to loop through each element in the value. That for x in values, it will loop through each element in the values. After that, result dot append, it will increase the result by multiplying 2 into 1 to the each element in the values, and it will store the result in the empty list. This is the little lengthy process. After that, I will get the output as 4.2, 6.3 and 16.8, which is multiplied by 2.1. If I multiply 2 into 2.1, I'll get 4.2, and likewise similarly. This is not convenient because the lists are just collections. It's a collection of values, not a mathematical objects. Right? That's why it is not that convenient. That's why to perform the mathematical operations easily, we use Numpy. Got it? Here we had a difficulty to perform the mathematical operations. That's why we come up with the new topic, that is Numpy. We can easily perform the mathematical operations by using Numpy. Got it? This is the basics of Numpy. Why we use the Numpy. Important, import Numpy as NP. This is the standard form we use in the Numpy. A is equal to np dot array. I have taken 2, 3, 8. A is equal to np dot. np is a Numpy. Here I am taking the expression 2.1 into a. It's very simple, right? And easy. In 2 lines of code, I can easily write an array. Here I will get array of 4.2, 6.3 and 16.8, which is very simple and clear as well. Got it? By using Numpy. Here we had a disadvantage. To overcome that, we come up with the Numpy. Clear with this? After that, we have some important key points in the Numpy. Import Numpy as Numpy, NP. It's a standard way to use the Numpy. You can see in the previous example, np dot array. Import Numpy as NP. Got it? After that, creating array. How to create an array? np dot array. In the previous example also, I have used the same np dot array. It will convert a Python list into a Numpy array. Here, it will convert a Python list into a NumPy array. Clear? After that, automatic type conversion. If you see the float in the operations, here in the previous example, I have taken the float. If you see the float in the operations, NumPy automatically changes into floats, ints to floats. It will automatically change the ints to float. Got it? If you see any float number in the operation, floating points in the operation, it will automatically change the integer number to the floating point number. Clear with it? I am explaining with the example for better understand. After that, element wise operations. Here a into a or a exponent a multiplies each element individually. If I take like this, it will go and multiply each element individually and give the output. Dot product means matrix maths. Here np dot of a into a, it gives the dot product, not element wise, it gives the complete dot product. It works like matrix multiplication for 2D arrays. Here np dot, the dot product works like a matrix multiplication for 2D arrays. Here np cross and np dot outer, it is for cross product and it is for outer product. These are also some useful functions in the NumPy. Use NumPy for fast, simple math operations and matrix calculation. If I want to calculate fast and simple, we use NumPy. Clear? This is all about basics of NumPy. And the next topic is shape of the NumPy. One of the most important properties of an array is the shape, its shape. We have seen 1D array, but arrays can have many dimensions. 1D array is there, 2D is there, 3D is also there. They have given some example just to tell that we have 2D and 3D arrays as well. For 2D array, we can see images are 2D arrays of pixels. And for 3D, we have color images have RGB values for each pixel, so that they are 3D as well. To get the shape of an array, use the shape. If I want to get the shape of an array, I have to use the shape method. Import NumPy as NP, which is the standard form to use the NumPy. A is equal to np dot array. I have told this point already. np dot array. I have taken the integer values a dot shape to get the numbers of the element. A dot shape. This is a 3 I will get. After that, if I want to work with the 2D arrays, B is equal to np dot array. Here I have a list that is 2, 3, 8 and 4, 5, 6. It is a complete list. Inside that I have 2, 3, 8 and 4, 5, 6. Again 2 more lists. Here it is a nested list. List inside a list. Clear? B dot shape is equal to here 2 and 3 because we have 2 rows and 3 columns. That's why it will give the output as 2 and 3. You can observe here 2 rows, 2, 3, 8, 1 row, 4, 5, 6, 1 row and 3 columns, which is 2, 4, 1 column, 3, 5 and 8, 6. Clear? This is how it works exactly. And shape tells the number of rows. The shape means what it will tell? It will tell the number of rows and columns. That's it. That's why it has written the 2 and 3. It will tell the rows in the first. After that, columns in the second. Very clear? Shape is nothing but it will return the number of rows and columns. Clear with it? After that, I have slicing. Why we use slicing in NumPy? Slicing is also same like list. We can select a specific value from a NumPy array. If I want to select or access the particular specific value from the NumPy array, I will use the slicing. By using slicing, I can easily access the specific values. Let us see how exactly it will work. For 1D array, slicing works like a Python list. Same Python list, it will work in the slicing also in 1D array. A is equal to np.array. I have taken an array in NumPy. A of 2. This is 0th index, first index and second index. A of 2 means this is the second index. I can easily access the value which is 8. For example, if I want to access from the first index, I will take 1 is 2. From the first index, whatever is there inside the array, I can easily get it. Clear? Array of 3, 8 from the first index. Clear? For higher dimensional arrays, how to access? Let us see with this example. B is equal to np.array. Here I have one array 2, 3, 8 and 4, 5, 6. Same as before. Here B of 1. If I want to access the B of 1, this is completely 0th index, first index. Okay. If I access B of 1, it will give array of 4, 5, 6 because it's 0th index. This is the first index. If I take B of 1 and 2, this is the 0th index and first index. In the first index, I want the second index. Again here it is 0, first and second. Here I will get 6 as the output because in the first index I am accessing second index. Clear with it? Okay, this is how I will get these two outputs. This gives the column we wanted. Whatever the column we wanted, it will give. Python starts counting from 0, not 1. It starts counting from 0th index only. Clear with it? The slicing, how exactly we will use and we can access the particular value what we want. Clear? And the next concept is masking. Masking is one of the most powerful features of NumPy. Why? Because suppose we have an array and want to remove values above a certain cutoff. I have an array, I want to cut off the value, the certain value. I want to remove that. Okay, certain cutoff. I can easily take a array. After that, cutoff is equal to 200. This is the condition. Cutoff, if the cutoff is 200 and if A is greater than the cutoff, if this condition satisfies, then only it will remove the particular value. Got it? Whenever the A means 230, 10, 284, 39 and 76. Whenever we will get greater than 200. If the A value is greater than 200, it will remove that and it will tell whether it is true or false and it will remove that and it will make it 0. Got it? Let us see with the example. A is equal to np.array 230, 10, so on. We have cutoff is equal to 200. I have taken 200 because I don't want 200. That's why I have made it cutoff is equal to 200. If A is greater than cutoff is 200. When the A value is greater than 200, it will cut off. Array of true, it is greater than 200. That's why it will return true. It is not greater than false. It is greater than 2. It is not greater than false and false again. After that, here this shows which elements are greater than 200. It will show only which is greater than 200. Here till here it will show only which is greater than 200. If it is greater than 200, return true or else false. Till here. After that, now we can directly set all values above 200 to 0 by performing this operation. A of A greater than 0, A greater than cutoff is equal to 0. If the A greater than cutoff is equal to 0, A greater than cutoff, we have to set it to 0 automatically. Again, we have to print the A. It will cut off to 0 directly. If it is greater than 200, the result will be 0. Array of 230 we have, which is greater than 200, it will set to 0. 10 it will return as it is, greater than 200 again 0. These two are less than 200. That's why 39 and 76 as it is. The key line is A of A greater than cutoff is equal to 0. Got it? This is why we use masking. Here it selects only the elements where the condition is true and changes them to 0. It will select only the elements. It will select only 230 and 284. Why? Because these two satisfies the condition A is greater than cutoff, and it is true and changes the true to 0. Got it? Without masking, we would need to loop through each element using if else. If we don't use the masking, we have to loop through each element and check. It is lengthy process using if and else if conditions and all, which is long and messy. That takes too much time and patience as well, which is too long and messy as well, especially for 2D and 3D arrays like images, which is very hard for 2D and 3D arrays. That's why we use masking, which is very simple and easily we can remove whichever we don't want. And masking makes array operations clean, fast and simple. If I don't want anything, I can easily remove by using masking. Got it? And it is very clean and fast and simple. Clear about masking? And the next concept is broadcasting. Broadcasting is a feature of the Numpy library that allows you to perform mathematical operations between arrays of different shapes. Got it? This is the broadcasting. For example, A is equal to np dot array. I have taken 0, 1, 2, 3, 4, 5. I have taken an array. B is equal to np dot array of, this is the A, this is B, np dot array of 10, 9, 100. If I want to multiply A and B, what it will give? Let us understand this step by step. Here 10, 9, 0. It will give 0. And 100 and 1. It will give 100. 2 and 10 it will give 20. 3 and 100 it will give 300. 4 and 10 it will give 40. And 5 and 100 it will give 500. This is how it will work. It will multiply. Got it? 10 into 0, 1 into 100, 2 into 10, 3 into 100, 4 into 10, 5 into 100. Got it? This is how the multiplication works in the arrays. That is broadcasting, which allows the different shapes of arrays. Got it? We can multiply, we can operate between the arrays of different shapes. Very clear? With this example, here shapes of A and B don't match. You can see here shapes of A and B. Here I have 3 rows and 2 columns. I have only 1 row, 2 columns. Got it? It doesn't match. Then also it will allow to perform the mathematical operations, which is mean by broadcasting. Numpy automatically stretches B to the match A shape and perform the element-wise multiplication. It will match to A and perform the mathematical operation, which is very simple. Got it? After that, we have some rules in the broadcasting. Only dimensions of size 1 can be stretched. Here the Numpy compares the dimensions from last to first. After that, if the dimensions differs and none is 1, broadcasting fails. Let us see the example for that for better understand. C is equal to np dot array 0, 1, 2, 3, 4, 5. Here I have taken B is equal to np dot array of 10, 9, 100. Here if I multiply C into B, it will fail. Why? Because the shapes here 2 and 3. 2 rows and 3 columns I have. Shape means shape is nothing but the row and column I have explained in the shapes. And here we have only 2. Got it? That's why it cannot broadcast. Here it will fail. Broadcasting fails. Clear? And how to fix it? How to overcome this problem? Add an extra dimension using none. I have to add one more extra dimension by using none. Let us see how it is done. C into B. I will multiply C and B, and inside that I will use none, comma done, comma none. Okay. It will return as array of 0, 10, 20. Here 0 as it is, 1 into 10, 10, 2 into 10, 20. After that 100 is multiplied with 3, 4 and 5. Got it? Here 0 into 10, 0 into 1 into 10, 2 into 10. Got it? 10 is multiplied with 0, 1 and 2, and 100 is multiplied with 3, 4 and 5. This is how exactly it's done. If the shape is not equal, it will return value error, and we can easily fix it by using none. After that it will multiply 10, 10, 0, 10 into 1, 10 into 2, 100 into 3, 100 into 4, 100 into 5. It will return the values like this. The mistake B shape 2 into 1 allowing the broadcasting with C. Here by using none we can easily allow the broadcasting with C. In short, broadcasting helps to perform the operations on arrays of different shapes. We can perform the operations in the different shapes of arrays also without looping and making numpy fast and efficient. It will make the numpy fast and efficient because we don't use the loop here, which is very fast and simple as well. This is all about broadcasting. After that we have D type, which is data type. Here in numpy, D type means the data type like int and float. These are the data types. It often has a number after it. For example, int 8, it has a number after it, int 8 or float 8 like that, which shows the how many bits are used. Here int 8 means 8 bits are used. If I take int 16, 16 bits are used. Int 8 means only one byte we have. 8 bit means 1 byte. 16 bit means 2 bytes. Clear? 1 byte is equal to 8 bits. 2 bytes is equal to 16 bits. Clear? That's why I have taken int 8, which means 8 bits. Here let us see an example. Int 8 uses the 8 bits. Got it? 2 power 8 means 256 possible values are there in the int 8. Okay, we can take 256 possible values. Int 8 means unsigned int 8. Only positive values we have to take from 0 to 255. The range is from 0 to 255 for int 8, which is only positive. Got it? And for int 8, it is signed. Int means unsigned, only positive values. Int means it will take signed, which allows the negative values as well, along with the positives. Here the range starts from minus 128 to 127 plus 127. Here it will allow only positive, it will allow negatives as well. This is 256 values I can store in the uint 8. Clear? 256 values. Bigger the data types hold the larger numbers. For example, if I take uint 16, I can store even more values. Because 16 means again the range will change. Got it? It will multiply. And I can easily store the bigger values. For example, int 64 can store numbers from this number to this number. Very big number, right? I can store even large number. Okay? It will store from this to this number. However, using a large data type when not needed was waste the memory. If the number is very short and I am using the bigger memory size, just waste of memory. That's why instead of that, we can easily use the int 8 or int 16 based on the value, based on the data we store. Got it? If your array values are small, like below 100, if the value is below 100, use smaller data types like uint8, it can easily save the memory. Got it? How we use data type and sizes, how we can store it based on the data. Clear with it? Here, if you store numbers larger than the data type can handle, they wrap around. For example, if I take larger number, but it cannot store that, the capacity of that data type is small because I have taken only uint8, which is, it can't store 200. Again, I have taken a plus a, which is 400. It cannot store it by uint8. That's why it will show an error. It will overflow and gives 144 extra. Let us see this. A is equal to np dot array 200. I have taken 200 and the data type is uint8. I can store only 256 values. Got it? If it is more than 256, it will exceed the value, overflow. I have taken a plus a. A is 200. A plus a means 400 I will get. It doesn't fit in uint8 because the value is 400. I can store only 256 values. That's why it will overflow and gives the 144 extra. How to fix it? Just take uint16. Very simple, right? If I take uint16, if the value is very large, we can easily fix it. A is equal to np dot array 200, same as it is I have taken. Data type I have changed it because here the value is bigger. It cannot store in the uint8, that's why I have changed it to uint16. Now I can easily store 400 in the uint16. Clear? In images, each pixel is stored as uint8. If I take the images, the pixels is stored as uint8. The values which is lesser from 0 to 255 only. It will store only the value is 0 to 255 only. If it is bigger than that, we have to use the uint16. For example, 000 is black, 25500 is a red. I can easily store in the uint8 these values. So data type is a very important for memory use and correct the calculations. It is very important to store the data in the memory and we can use it. If any changes or any modification is needed, I can easily change the memory, which is uint8 to uint16. I have increased the memory size. Got it? If the value is big, I have to change accordingly. Very clear with the data type. Here completes the part 2 of the module 3 and I have explained Numpy, about Numpy basics, shape of the Numpy, slicing, why we use slicing, masking, broadcasting and data types. These are all the topics covered in this video. If you found this video helpful, then subscribe to Explore Electronics and share this video with your friends who are struggling in Python programming, and make sure you watch the previous modules and parts as well for better understanding. Thank you very much for watching. See you in the part 3 video where I will explain about files. Thank you.